Thanks, everyone. So today we're going to talk about microservices. Just by a show of hands in here, who's worked on a microservice architecture, decomposed the big monolithic application? Okay, cool. So quite a bit of hands went up there. So we'll talk a bit about today, just kind of the pattern for anyone that's not familiar with it. We'll look at some of the things that are unique about microservices in terms of security architecture, and we'll talk about solutions instead of just saying the world's broken. So at a high level, the pattern, we'll look at things like data, asset, and inventory, right? So we move a lot faster. Let's think about how to do that in a sane way. And drilling down to the bottom, I was going to talk about RASP and top 10 lists, but then I want to talk about security. Bad joke, too soon, sorry. Moving on. So with regards to microservices and the definition, so microservices just kind of like Agile and DevOps and religion and other things that if you ask 5 people what their definition is of that, you'll get 5 different answers back, right? So with regards to microservices, there are some common traits that we see across different services. So doing things like building your applications to be completely independent with regards to their life cycle for deployment, upgrades, deprecation, and stuff like that. We kind of try to organize things around business functions. And we definitely don't want one service to bring down pretty much everything, right? So for example, we don't want the billing service going down to bring down authentication. So with regards to having an independence, we also hope that that translates to basically not having failures kind of knock everything down. So in terms of some of the properties we look at, independently deployable, right? So once upon a time, we had a big struts app. Now we pretty much maybe have 5, 6 different stacks. Decentralized management and governance, right? So once upon a time, we had one application team and they wrote this big thing and it talked to like an Oracle backend, right? And nowadays, you know, you might have dozens of teams working on different services. So if anyone's familiar with Amazon, they went to the, what was it, the 2 pizza model a couple years ago, right? Where teams aren't bigger than where you need 2 pizzas, but lots more teams than just one team, right? Smart endpoints and dumb pipes. So that's a Martin Fowler term. I just pretty much took that one. But what you get there basically is once upon a time, right, especially in like a service-oriented architecture, enterprise service bus, we used middleware and things heavily, right? So we would basically, you know, put business rules, business logic in there. We let that middleware handle things like routing and stuff like that. In a microservice world, we want that intelligence to exist in our services. We do centralize some things like authentication, like we'll talk about. But generally, we move that logic into the individual services themselves. So, microservices simplify everything, right? Sounds good? Totally not true, right? In reality, microservices, from my experience, tend to add a lot of complexity, a lot of overhead in that regard, right? So anytime you see an architecture diagram and you start kind of drawing more lines, right, you just assume there's additional complexity. But in reality, kind of looking at something like this, right? So once upon a time, we had that big pile of struts on the left. So if you think about that, that ran in a single JVM, right? Basically, the data flows were pretty well defined, right? We had a client that hits a web server. That web server maybe talks to a database, maybe that talked to something else in the service-oriented architecture. But it was pretty well defined, right? And you know, in a traditional monolithic application, looking at that diagram, it probably didn't change crazy much year over year. But then that big struts application gave birth to 12 other little piles of code, right? So these microservices now can potentially run different processes, different technology stacks, right? So, you know, once upon a time, it was like, hey, let's instrument the JVM and block everything, right? Well, maybe you don't have that commercial tooling around, you know, a specific stack, right, a specific VM. So you'll kind of find that, you know, you're not going to have one tool to kind of kill them all in this regard. So here's an example, just thinking of it from the Amazon perspective, right? So what you see on the outside is Amazon.com. What you see behind the scenes are a lot of different services to handle things, right? So we'll have a service for orders, we'll have a service for reviews, inventory shipping, but regardless, these can often be different teams building them with different life cycles and all that stuff, different technology. And here's an example of just a really simple architecture diagram of a microservice architecture. So I'm going to use my handy little pointer here. And so first off, we have an API gateway. And the API gateway is essentially what everything's going to go through with regards to getting into that architecture. So that's going to handle authentication for us. So we can authenticate mobile clients, web applications, your refrigerator if that's your thing. But regardless, in a good microservice architecture, we force everybody through one pipe for authentication like that. Behind the scenes, we have a bunch of other services. So we have accounts, we have order history, we have billing. So if you notice, if you kind of follow the lines, they all end up communicating with Apache Kafka. So does anybody use Kafka? We use Kafka in my shop. Love it. It's great. But regardless, so each of these services will essentially pass messages, and then services that are interested in consuming events and topics can publish or can subscribe to things rather. So with regards to coupling, it's maybe in that way, but it's very loose in that regard, right? So we're not hard coding and wiring up these crazy dependencies. And we have the ability to pretty much tear stuff down at will. Going a little bit further, you'll also notice that each of these has its own data store, right? So one service, for example, uses Cassandra. The shopping cart uses Redis. Within my shop, we actually do something similar, right? So depending on the data, what you're doing with it, right? Cassandra may be a really good fit, right? So for services that are very write-heavy, that can actually benefit from Cassandra's wide columns and stuff like that. Perfect, right? So microservices let you pick essentially the right tool for the right job. So first up, right, what's not new? We're exposing APIs, we're exposing APIs to the world. So newsflash, you should secure those. Things we know, SQL injection, there's not some crazy new cross-site SQL injection, forgery something, right, or some other buzzword that someone's going to sell you. These things are the same. What does change, though, with regards to moving from essentially a monolithic application in a single process, like, say, JVM, and now we're distributing that, and maybe we're passing that data over a message queue before it gets to wherever that sink is, right? So with regards to basically tracing from source to sink, we lose that visibility, right? So we just hope that the consumers of our data are handling it as safely as we do, right? So if anyone works in a shop with a bunch of data scientists, that their goal is to pretty much get all the data, hoard the data, figure out how to structure the data, query the data, right? We just assume that they're grabbing that data as often as they can and doing stuff with it. So hopefully they're doing things like escaping the data, sanitizing it, encoding, and all that jazz, depending on what they're trying to protect against. But the key thing is that we've distributed the workload and responsibility across the architecture. Very important to think about. So let's just look at data and asset inventory and how this stuff unfolds. So once upon a time, in this perfect world we used to have, we released 3 or 4 times a year, right? We'd sign off on the release and somebody would, I don't know, copy a jar over to like a server and like then we'd be on the internet, right? That's really changed, right? So from container orchestration platforms to continuous integration and delivery, platforms as service features, right? It's just totally different life cycle to how we approach this. So when life was easy, you had an application that kind of looked like this, right? You had a client, talk to a web application, talk to a database, right? So with regards to, thinking about where's your data propagating throughout that architecture, it's not really hard to figure that out, right? Maybe it's ending up in logs somewhere. Maybe we have, some type of logging mechanism on top of this, but it ends up in the database and maybe a couple other places. Developer laptops, right? Lo and behold, everything's on those things. So now we basically create our infrastructure as code, right? So if anyone's using something like Terraform, CloudFormation, right? So it's easier than ever to spin up infrastructure in a couple files, right? So that sounds really scary, but then there's also huge opportunities in that, right? So you don't have to basically chase down some crusty DBA that you talk to once a year. You can actually kind of see all the stuff and maybe manage it centrally, right? So I'd argue that you actually do have opportunities here. But it is fairly newish territory for a lot of teams, right? And when they hear we're using infrastructure as code, it's like, oh my God, catastrophe. Here's just an example if anyone's never seen what like a Terraform configuration looks like or CloudFormation. So that might be extremely blurry in the back. This one here, for example, is a CloudFormation template to spin up DCOS on AWS. But nonetheless, right, you define a couple nodes, you define what the VPCs, what the network looks like, and then you spin it up, right? So you get, network in a file, right? So what changes, right? So once upon a time, you had a bunch of people, configuration, control board, and stuff like that. And now you have a master branch, right? So it definitely gets important if you consider, like, who can actually commit to master, right? Do people need to submit pull requests? Can people just change things in master? Because essentially what could end up happening is you commit to master, and then pretty much that gets committed to prod, right? Different. But it is great for things like auditability and change management and stuff like that, because you have one centralized place where you watch those changes happen, as opposed to dozens and dozens of systems that you need to tie together with different logging mechanisms and SIMs and whatever other stuff you use. So container orchestration is a big thing. These are the big boys there, right? Kubernetes, DCOS, Docker Swarm, OpenShift. I'm sure somebody uses at least one of those in this room. But regardless here, so now it gets even easier to just spin up things, containers, and scale those really fast, right? So pretty cool tech. And in the serverless world, if anyone's using things like Lambda, so I'm really a huge fan of Lambda. We use Lambda a bit. If I had to pick, we wouldn't actually have any servers or systems. We'd just all be functions. But nonetheless, in a Lambda world, essentially, and in cloud functions, you have 300 seconds to come back and finish your work. So you're generally not doing things like heavy batch at that point. And with serverless, people have kind of started to recommend going with mono repos. What does that translate to? So putting all of your functions essentially in one repo so you can track those, right? As opposed to having dozens and dozens of repositories. So with regards to kind of track down, where are all the functions running? Do we want to run static analysis across those, right? We can organize those by one big repo, which is ironic because we've gone from like monolithic applications to microservices, and now we're just kind of, we need to bring some kind of monolithic aspect back to it, right? And security tools with performance hit, right? So if you want to run something that incurs 30-40% penalty on Azure, Cloud Functions or Lambda, you're probably going to piss some people off, right? Essentially, you're spinning up and spinning down often in milliseconds, right? So runtime maybe isn't the place where you inject security. At least not yet from the technology I've seen. So where does my data end up? In a nutshell, everywhere. So I have a kid. I can tell you toys end up everywhere in the house. Within your teams, I guarantee your data ends up everywhere. Does anybody use, or anybody see anybody use like Zeppelin with Apache Spark? You ever see any good stuff end up in a Zeppelin notebook? No? So I've seen data science teams just hoard some incredibly interesting things, right? From patient data to financial data. But nonetheless, depending on, what type of shop you are, and what you're, on the hook for compliance purposes. I mean, privacy is everyone's concern, but I mean, if you don't have patient data, you don't have patient data. But nonetheless, depending on what you're doing, it's really important to understand once the data leaves your service and goes somewhere else, you don't know what's going to happen to that data persistence lifecycle, right? Is that going to be stored in memory in Apache Spark? Is that going to be stored off heap by replicating with something like AppSecEU, right? You just don't know unless you have visibility into what those teams are doing. So it's a good exercise to think about where's that data going to end up, what services are going to consume it, etc. So let's talk a little bit about authentication here. We looked a little bit at the API gateway at first. So the API gateway is generally the authentication pattern you're going to see here. So if anyone's familiar with a facade, we essentially have a single entry point. That's essentially going to encapsulate essentially that internal architecture, at least from the externally visible perspective, right? So the outside sees the gateway and routes. Internally, you have essentially dozens of services and routing and all that jazz behind the scenes. What it allows you to do is essentially do authentication in one place and then pass that identity through different means we'll look at down to those microservices. So you're essentially abstracting those services from handling outright authentication, but you essentially let them handle the business rules and everything else, authorization, access control wise at their level. And there's a bunch of implementations out there. We particularly use AWS's API gateway. We started out with Kong, but we realized quickly it didn't do what we needed, so we moved on. You're welcome to pick which one works best for you. And here's just an example of what that looks like from an architectural perspective. Behind the scenes, we use things like Lambda, right, to do post-processing, pre-processing hooks on that. So we have the ability to do things like check roles and stuff like that upstream. We use Cognito as well for identity provider behind the scenes. So There's similarities in other platforms. We particularly use this one. It handles things like MFA and stuff like that, and it just makes it incredibly easy to do things. And here's an example of shoving Cognito in there. So essentially, the API gateway uses Cognito for user pools and stuff like that, handling user attributes creation. So it's a really quick way to basically spin up authentication and pretty much have a really good data store that lets you do a lot of things. It also forces you to sign requests, right? So I actually like when architecturally we can just break class of things. So if you're doing things correctly, of course, in the absence of cross-site scripting, this actually makes it harder to get CSRF to work. And additionally, does anyone use Swagger in here? Document, cool. So Swagger, first-class citizen of the API gateway. I really like things like Swagger just because it makes it really easy to publish capabilities across teams, right? And once you get past the gateway, you can do things like pass in pretty much who the user is, what their role is, attributes, entitlements, etc. And you could basically integrate with Lambda to do all that stuff. So let's take a quick look at access control and identity management. So we've decentralized things. So by nature, that makes things a little bit harder. But using things like API Gateway in conjunction with JSON Web Tokens, JWT, can actually make it easy to share that information across services. Additionally, if anyone's familiar with CQRS, which we'll look at in a minute, it's a really cool pattern, and we can actually use it for security. So JWT, love or hate JWT, it works really well here. And even frameworks like Play have actually gone to using JWT for default session. But nonetheless, JWT is a really nice way to essentially sign and pass these claims down to services to let them know who the user is. And here's just an example of kind of what that looks like using it in a Lambda world. You have the API gateway. The API gateway will get the JWT from the client, and then it can pass on any of that information about the user's principal and whatnot to those downstream services. So we can let the downstream consumers figure out things like resource level access controls, because it's just really hard to abstract that up here when you don't know the granularities of the rule of each of those services. So you let the services handle that. You can do things at the gateway in Lambda, like for example, if a user doesn't have a subscription, maybe they don't hit a service that requires a subscription. It just really depends on your architecture to determine how you distribute that. CQRS, so command query responsibility segregation. CQRS is really nice because it allows you to separate your read and write interfaces. And if you take it a step further, you can also basically translate those down to actual models, where essentially some calls can read, some calls can write. And in a microservice world where things are pretty complex, it actually is nice to have that level of granularity. But it's an architectural thing, an architectural pattern, and something you think about as you architect. Here's an example of what CQRS looks like. And basically here you have a presentation layer. You have commands, you have your domain logic, but more importantly, you have a write data store, you have a read data store. So depending on what you want to expose, you have maybe a little bit more control than if you just assume everything that hits this maybe has read or maybe has write. It allows you to architecturally separate those concerns just a little bit further. And what about between services, right? So we talk about the user, we talk about the user's allowed to do, but what about between services, right? So in this example, hopefully you can see that in the back. We use an example with Apache Kafka of publishing credit cards. I've maybe seen something like this in real life. So basically what ends up happening is one service says, hey, I need to publish something about payments, right? Another service that consumes it. And then someone on your data science team says, I'm really interested in how this stuff happens, right? So now I want to consume that, right? So we haven't set authorization between things to determine who can publish and who can subscribe. Now anybody can essentially stand up a new service and subscribe to that, right? Which means we have a problem because now we don't know where the hell those credit card numbers are going to end up, right? So obviously there's things, and Kafka wasn't that great before 0.9, but there's a lot more you can do with authorization in the modern versions. You shouldn't basically leave it wide open like that, right? You should have some control over who can publish and subscribe. You need to think about those things. I like to build something out as restrictive as possible and then pull calls later on. Works for me. Last topic here is securely sharing secrets. So in a microservice world, and especially, we don't deploy microservices to basically bare metal, right? We're using containers, and we're using serverless functions to build these things. So for starters, you don't want to basically pass those around in the plain text. You certainly can. It makes it very easy to do it, but there's much better options. So for starters, bad ideas. Don't hard code credentials in your code. We know that. Don't hard code credentials into your Docker files. And don't use environment variables to pass secrets. So you see this bad information on the web all the time, like use an environment variable to do it. When you pass things with environment variables, every process on that container can essentially read that, right? So you maybe want to limit that visibility just a little bit more. And here's an example of just the most egregious version, hard coding into a Docker file. Hard to see from back there, but we have root password as password, right? Don't do this. I guarantee you, you have a better option than this. So don't do it. The other one is basically using environment variables. So Docker lets us pass in variables. Don't do this either, right? Because for starters, you still pass in the same way. Everything can read from it. And you also do risk, leaking these things in different dashboards, different logs, shell history, stuff like that. So is there a perfect solution? No. In my opinion, Docker is leading the pack at this point, primarily because they're doing maybe a little bit more in terms of protecting secrets at rest. But Kubernetes, DCOS, and OpenShift do have options. So here's an example. It might be hard to read somewhat, and you're welcome to probably get this in the slides after, but just an example of how we can pass in secrets to a Kubernetes pod and then let those pod members read from essentially a mounted partition. So is that perfect? Not really. So Kubernetes will handle from the perspective of passing them in securely, and then you can implement, essentially Unix file system permissions to get a little bit more control beyond that. What you don't get is protection at rest. So etcd is going to basically store them in the plain text, which is better than the other route, but you still do have exposure points, right? So you do need to think about that Kubernetes box that has all the secrets. Maybe you don't want it on the internet. There is a proposal, however, to encrypt secrets at rest. So Docker uses some things like key encrypting keys and stuff like that. And it looks like from just basically the proposal and the specs that they're going to adopt a similar route. But that'll be really huge, I think, when they do it. OpenShift actually just this last week announced support. They integrate more with Vault, if anyone's used HashiCorp's Vault. But it goes back to the same exact issue at the bottom, right? That secrets are still unprotected at rest. So we haven't solved that problem there either. So in summary, in a microservice world, I've at least found that it's probably everywhere in security architecture, right? That it's easier to think about it earlier on. And especially in a microservice world, as things are essentially very decentralized, independent life cycles, it's probably more important than ever to get security into that architecture early on, or at least put things in place that are going to force your developers to develop around secure patterns. That's my talk, everybody. Thank you very much. If you want to get in touch, you can find me on the internet.